To my presentation. In this presentation, we shall see the proof of power rule. So let us get started here. Let the function f of x is equal to an exponent x to the power of n, in that form. Applying the derivative of a function using limits, we know that f prime x, or the first derivative of the function, can be written out as limit as h approaches 0 f of x plus h minus f of x, this whole thing divided by h, and applying the function into the formula, we can write this as follows. F primes of x can be written out as limit as h approaches 0. Now we are applying the function into this formula. Instead of, we have x plus h, this whole thing is raised to the power of n, minus x to the power of n, and that is what the given function is, the whole thing divided by h. We have substituted the given function into the formula, and now we're going to expand this using the binomial theorem. So if we take according to the binomial theorem, let me write here. I'm going to write the binomial theorem in another color, and then come back and then expand x plus h to the power of n in another color. So we know that the binomial expansion is as follows. But let me write here. The binomial theorem expansion is as follows. If we have, let's say, if we have p plus q, and if this is raised to the power of n, we can, according to the binomial theorem, the expansion is as follows. P to the power of n plus np to the power of n minus 1 q plus n times n minus 1 divided by 2 times p to the power of n minus 2 q to the power of 2, and then I'm going to put a couple of dots indicating that it goes on, and then we can write the subsequent terms as follows. N p q to the power of n minus 1 plus q to the power of n. That is the binomial expansion. Now if we were to replace p by x and q by h, then we can apply this to what we have in our problem here. So therefore, I'm going to go back to the black ink and then write it out as follows. We want to expand x plus h to the power of n, and instead of p, we are replacing it by x. Instead of q, we are replacing it by h, and therefore the expansion is going to follow the same binomial expansion like what we have shown here in red. So this is going to be x to the power of n plus n x to the power of n minus 1 h plus n times n minus 1, the whole thing divided by 2, times x to the power of n minus 2 times h to the power of 2 plus, and there are several terms in here, so we're going to write the second last term and the last term. Nx to the nx, n times x times h raised to the power of n minus 1 plus h to the power of n, like that. Okay, we can write x plus h, the whole thing raised to the power of n, minus x to the power of n as follows now. So in this step, we want to know the numerator part is like this, isn't it? X plus h this whole thing raised to the power of n minus x to the power of n, and that is what we want to simplify. And this simplification process is as follows. We're going to write this one as x to the power of n plus n x to the power of n minus 1 times h plus n times n minus 1, the whole thing divided by 2, x to the power of n minus 2 times h to the power of 2 plus several terms plus n x to the power of n times x times h to the power of n minus 1 plus h to the power of n minus x to the power of n, and this is that minus x to the power of n which is in the beginning of this equation here. So as we can see here, x to the power of n and then negative x to the power of n cancels out, leaving us with these type the rest of the equation in here. So now therefore, in our next step, what we want to write is this: x plus h, this whole thing raised to the power of n minus x to the power of n whole divided by h is equal to, I'm going to draw a line and then write here, if we look at these terms now, n x to the power of n minus 1 h, in all of these h is common. So I'm going to pull out h common and then write this rest of the equation as follows: n x to the power of n minus 1, that is the first term, plus n times n minus 1 divided by 2 x to the power of n minus 2 times h plus, and then we have several terms in there, I'm going to put dotted lines that way, plus n x to the power n times x times h to the power of n minus 2, because we have h to the power of n minus 1 when we pull out h common, so it is going to go to h to the power of n minus 2 like that, plus h to the power of n minus 1 like that. I'm going to close brackets there, the whole thing divided by h. We have an h there. So as we can see, the h in the numerator and the h in the denominator cancels out, and therefore now we are ready to apply the formula, or ready to apply the limits now. Now if we were to say limit as h approaches 0, x minus h, the x plus h, this whole thing raised to the power of n minus x to the power of n, the whole thing divided by h. We can write this one out as limit as h approaches 0. The first one is nx to the power of n minus 1, like that, plus limit as h approaches 0, n times n minus 1, the whole thing divided by 2, times x to the power of n minus 2 times h, plus, and I'm going to put some dots in here indicating that there are several more terms in between, and we're going to write the last two terms in here, and those are limit as h approaches 0, brackets, open brackets, n times x times h to the power of n minus 2, like that, plus limit as h approaches 0, we have h to the power of n minus 1, close brackets. Now as we can see from here, that as limit h approaches 0, x plus h, this whole thing raised to the power of n, minus x to the power of n divided by h. This is going to be equal to, this we can write as nx to the power of n minus 1, or let me back up here and then say we can write this limit as h approaches 0, x plus h, the whole thing raised to the power of n, minus x to the power of n, the whole thing divided by h. We can write that as the first derivative of x is going to be equal to, in here, the limit as h approaches 0, nx to the power of n minus 1 is going to be nx to the power of n minus 1, plus limit as h approaches 0, n times n minus 1 divided by 2 times x raised to the power of n minus 2 times h. That goes to 0, and then we'll put a couple of dots there and then write their last two terms. The last two terms are limit as h approaches 0, n times x times h to the power of n minus 2, that goes to 0. I'm going to put that goes to 0. And then the last term, limit as h approaches 0, h to the power of n minus 1, that also goes to 0. Therefore, I can put a 0 there. And therefore, we can come back and then say, if the given function, if f of x is equal to x to the power of n, then we can say, I'll write then, the first derivative of that exponential function or the power function is nx to the power of n minus 1. That is what we have seen from here. I'm going to put a box around this, and then the plus 0, and then there are zeros all along that part there. Therefore, we can drop all the zeros and then say, if we have a function which is x to the power of n, like that, the first derivative of that power function is going to be nx to the power of n minus 1. So this is what we are interested in. This is what is called the power function. This is called the derivative of the power. This is the power rule. In my next presentation, we shall solve some problems using the power rule.